So today I'm talking about the CSR bench, which is a benchmark of large language model agents' ability to deploy computer science research repositories. So I will cover the background, how is CSR bench constructed, and also CSR agents, which is a framework for automated code deployment, and also the workflow, as well as results. So let's first think about this. So nowadays, large language model is able to write code, is able to even compose some code repositories, or even fix issues like Cursor does. But there isn't too much research on the automated deployment of code repositories, which in this era of like AI coding is everywhere because we have more code repositories. So I think the automated deployment is also worth studying. So this work aims to bridge the last mile, which is deploying the repository automatically. And there are two components. The first one is CSR bench dataset. The second one is CSR agent. So to construct the dataset, for each sample, we selected the three parts. The first is the code repository itself. It's just like Azure Git clone, that part. And second is the issue database, which is not generally collected if you just use Git clone. And the third is the meta information. This is for the purpose of reproducibility. And here is the source distribution of this dataset. We can see that from the conference. We have NeurIPS, we have ICML, ICR, also NACO, CVPR, etc. And as for the topics, we aim to cover as comprehensive as possible. So like CV, NLP, ILM, and interdisciplinary research are covered. So before we go into the agentic workflow, let's first take a look at the evaluation task to give you a better idea about how this system works overall. So you can imagine like you are tasked with running a repository. So the first step is you clone the repository, and then you usually will read through the README to see the instructions like pip install or conda install, and then wget some files, and then probably like set up some environment variables. So for our task, the input would be the repository file structure as well as the README. And then we have the agents to comprehend their instructions and then attempt to write a bash script that will automatically deploy step by step. And I would say most of the time the agent cannot successfully deploy the commands on the first try. So we also have the environment, which is a Docker environment with a large language model parser to parse the system output. So those logs, if failed, those logs will be transferred to the CSR agents, where the agents will use either web search tools or like RAG against the issue database to refine the commands. And here comes the workflow. So overall, there are 4 agents working sequentially towards the task of automatic deployment. So the first agent is the command drafter, which you can view it as a more general purpose agent that extracts all the commands, like bash commands from the README, and try to categorize them. We will also see those categories later because we can see that agents' ability in deploying the commands from different categories differs a lot. And here is a example here. So yeah, just to give you a little bit more about context. So imagine you are tasked with running this Alpaca LoRa repository. So after you clone it, you may just read through it. And then, well, the first command here is pip install -r requirement. So what the drafter agent does is just like a very junior junior researcher does, is just like copy and paste. And well, the first one, the pip install, it successfully installed all the requirements, so that's a good thing. And then after this, it proceeds with the next commands, which is the training. But this time it's not that lucky. It says there is no module named PEFT, because somehow maybe in this repository the author forgot to put this requirement in it, or there's some conflicts, but somehow it didn't went through. So imagine this case, the agent is no longer able to resolve it, so that's where the second agent comes in place. The second agent is a log analyzer, and this agent will see the parsed output from the operating system and try to fix it. And yeah, there is one large language model embedded in the Linux system that will parse, because sometimes we need to set up some environments, like environment variables, so we do not just use like the Python, we do like system level interaction. So that's why the large language model is also needed to parse the standard out and standard error. All right, so for the analyzer, we also have an example here. So the left column is what the first agent does. It failed to resolve the issue. So imagine we are running some repository and we find that, well, it failed. So our reaction should probably be like, we read the error log and see, well, what is a possible issue, right? If we see, imagine if you see an error like no module named PEFT, we may just like do pip install PEFT, right? So that's also what the analyzer does. So it's suggested that do pip install PEFT and Python fine-tune script. So it also, so that's the right column is the output. We can see that the PEFT is successfully installed, but the issue still persists. It's like another issue raises, which is this function is no longer exists in that module. Did you mean like prepare model for k-bit training or something? So that could be some issue, like that could be some like a version reason, right? Versioning stuff. So that's where the third agent comes in place, the issue retriever. This is a RAG-based agent that will retrieve the issue database, which we prepare in advance, I would say, to retrieve the top K relevant issues and use those issue corpus as part of the information in the command refinement. So here is also one example about this. So it's just like, well, if you do copy and paste and it didn't succeed, and also then you try to pip install the PEFT, and still there is some like version issues. So what will you do next? Probably you would just go to the original GitHub repository and search the issue database to see if there is any earlier issues on this topic. Right, so that's also exactly what the third agent is doing. So the retriever will retrieve all the closed issues and find the top 3 hits as part of the context to solve the problem. And on the right corner side, lower corner, you can see this is one actual example of the input to the AI agent. So by the way, we also, for each message, we also tag the user who sent the message aside of it, so that the agent, when reading this, the agent can figure out which message is sent by who and which person has really solved the issue. And the suggestion from the GitHub is like the easiest way is to use an older version. So AI agent also detect this. So what it's suggested is, sorry, it should be on this slide. So what is suggested is install from GitHub on the earlier version. Like you can see that it's it's GitHub at a certain commit ID. So yeah, so that's the third agent. Most of the time, the first 3 agents, I think it's good enough for the repositories that are well written, but sometimes there could be some issues that need some external information to solve. So that's the fourth agent, which is a web agent. The web agent will first summarize the log issues, because we don't want to search a very long paragraph in the internet, because generally you find nothing. So it will first find the key points and then search the web for any valuable feedback and use that as part of, say, it's just like RAG as well. So here is also a quick example about this. Generally, the web search agent in CSR agents just use a template. It's like, first it will say which command is being run and what are the system logs, and then find any relevant responses. So in this case, I show here is some issue related to CUDA driver version. So it has a CUDA version installed here. And next, let's talk about the CSR bench evaluation. So for the evaluation, the overall goal, I think, is very clear, as we talked about before. Is just how the agent is able to automatically deploy a code repository in computer science field. And the metrics in general is all the number of successfully executed commands over the total number of commands that is executed. I would say if we have more human curated data set here, it would be better. But for this case, we just use it because it is fair for every model, so it's okay here. And here is some visualization of the results on Cloud 3 and also GPT-4o. For more results, we also have them on the paper. But here I'd like to highlight three things. The first is, if we compare left-hand side, those two pictures, we can tell that generally cloud models is better at writing such bash scripts. And second is, if we focus on the left image, and there are 5 groups of Rs, right? So the first 2 groups is much higher, I would say, than the following 3. I think this is intuitive because the environment setup or like download, generally it's just commands like pip install, conda install, or like wget or curl, those commands, which is generally like independent of the machine or the operating system. While the other 3 is generally dependent on the machine, on the file structure, as well as the previous setup. And the last thing is, the most significant improvement, if we focus on the first group, comes from the blue bar to the yellow bar. So that's also one of our conclusion, which is when we are developing such agents with the aim of automatically deploy some repository, it is very important to have the interaction with the environment, because no matter how capable an AI system is, if it knows nothing about the machine specs or the runtime environment, it's really hard for it to compose very good scripts. Yeah, so the conclusion is here. So first, the CSR bench is a benchmark on large language model agents to automatically deploy computer science repositories. And second is agents are very good at the first 2 tasks, while it suffers in the last 3 more. And the last conclusion is what I said just now, is the interaction with the environment is very important in developing those agentic AI. In other words, feedback from the environment can help the agents to refine their plan or refine their next steps very, very efficiently. Yeah, and that's pretty much what I want to talk today. Thank you for listening.
Thanks for the presentation. This is a very